Hello, everyone. My name's Kayla. I'm a tutor at Woodland Community College. Hopefully, some of you guys have already met me in person. If not, I'm sorry I'm not available this week. And so I wanted to make a video so that you guys could still have material to review with me while I'm gone. So, what I'm going to do for this video is I'm going to just share my screen and just kind of go over some of the things I would have gone over if I was actually in the center. So for now, this first video is going to be talking about general bone anatomy, and then the next two will talk about the specific parts of the skeleton, the axial and the appendicular skeleton. So let me just get started. So obviously this is bone anatomy, so this is just the general anatomy of bones and just the basics. So to start off, we have the skeleton, and the skeleton is composed of 206 bones. That might seem like a lot, but when you get down to it, there's a lot of bones that are really small, or there are multiple of the bones, such as the metacarpals and the phalanges, and the vertebrae and the ribs. There are a lot of them, and they're each individual bones, but we categorize them as bigger structures. What's interesting about bones is that each individual bone is considered an organ because it's made up of multiple tissues. So the dominant tissue is obviously bone connective tissue, and the other types of tissue within it is nervous, blood, cartilage, and various epithelial tissue within each bone. So there are two general types of bone formations. So you have compact bone, which is very dense structures within the bone, and you have spongy bone that is made up of these column-like structures that looks like a sponge, and they have a lot of space within these sections compared to compact bone, which only have small openings for blood and nervous vessels. So now here are the different types of bone shapes. There are multiple classifications of bone shapes, which help categorize the different types of bones there are in the body. So the first type of bones I'll go over are long bones. These are bones where the length is larger than the width. So here you can clearly see, obviously, the bones are very long, hence why they're called long bones. And some examples of these are the femur, humerus, radius, the phalanges, and the metacarpals. All of these long bones have more compact bone than they do spongy bone, and we'll get into the specific gross and microscopic anatomy of these bones in a minute. But these are just some examples that you will go over many times. The next type of bones are short bones. These are classified as somewhat cube-like bones, and they are mostly made up of spongy bone and less compact bone. Many of these bones are in the carpal and the tarsal bones, which these images will definitely be helpful for reviewing these type of bones when you get to the appendicular skeleton. So I will also be including a link to this slideshow, with all of these images so you can study them later. Then you have flat bones, which while they are called flat bones, a lot of them have curves, but they're mostly defined as having both compact and spongy bone. They typically have two layers of compact bone with spongy bone in between, almost like a sandwich. And so some examples of these flat bones are the bones of the cranium, which is the frontal, parietal, occipital, temporal, and sphenoid bones, as well as the ethmoid within here. And then the scapula and sternum are also two other types of flat bones. You have many different types within your body. These are just some examples. And then you have irregular bones. These are bones that don't really go into any other category. The main example of irregular bones are vertebrae, as they have a very specific structure that is not really aligned with any of the other types of bones. There's also one more type of bone The sesamoid bone. I believe the only sesamoid, maybe not the only, but the most prominent sesamoid bone is the patella. And as you can see, it looks almost like a sesame seed, which is why it is called the sesamoid bone. Next, we have the gross anatomy of specifically the long bones, but the gross anatomy does apply to more than just long bones. So with long bones specifically, you have different sections of the bone. So you have what's known as the epiphyses. So you have proximal and distal epiphyses, and you have the diaphysis, which is the long section in between the two different epiphyses. The epiphyses are easily seen with the epiphyseal line. Well, you cannot see it from the outside of a bone. If you were to cut into a bone, you would be able to see the epiphyseal line, which will be the defining characteristic to separate the diaphysis from the epiphysis. And there would be one down here as well, but obviously we cannot see it from the outside of the bone. The entirety of the bone is covered by the periosteum, which is a translucent membrane that helps protect the bone and it helps protect the bone, and it also allows for other it allows for there to be less friction between the bone and any muscles or any other organs that would be coming into contact with it. At the top and the bottom of the bone, you have articular cartilage. And the articular cartilage is made up of hyaline cartilage. And so there's thick amounts of this cartilage at the areas of the bone that would attach to some type of joint. So for this example, this is the humerus, I believe. And so the humerus up here, it would attach to the glenoid cavity. And so this section right here is the head of the humerus, which is covered in the articular cartilage to allow for more structure and protection for when it is in that cavity to create the joint of the shoulder. Within the bone itself, you have the spongy bone, which is typically, there is a lot in the epiphyses, so you have it both in the proximal and distal epiphysis. And then you have compact bone that lines the entirety of the bone, and you see a lot more of it in the diaphysis. While there is some spongy bone in the diaphysis, it's a lot less than compact bone. And then deep to the compact bone, you have what is known as the medullary cavity or medullary cavity. You can kind of pronounce it whatever way. And this cavity is covered by endosteum. So while you have periosteum on the outside, you have endosteum on the inside. That is going to protect the compact and the spongy bone. The medullary cavity can be filled with mostly yellow bone marrow, which is primarily fat. Another structure, it's within the periosteum, you have nutrient foramen, which are basically holes in the periosteum that allow for nutrient-rich arteries to pass through to go into the actual bone to provide nutrients to all of the bone structures. You also have what are known as perforating collagen fibers, and these collagen fibers are going to keep the periosteum attached to the compact bone. Next, we have microscopic anatomy. So for mostly compact bone, you have a lot more microscopic structures. The main structure I'm going to focus on first is the osteon, also known as the Haversian system, but most of the time we call them osteons. So in these osteons, you can see there's a image here, which would be from a slide, and then you have a diagram here, and I'm going to focus on the diagram for now. So in this diagram, you can clearly see you have these circles or rings around what is called the central canal. So while this is not enclosed, you can see clearly here the central canal will be enclosed, and then you have the rings around it. So these rings are called lamellae. And within the lamellae, you have the lacunae, which are enlarged portions where the actual osteocyte or the bone cells will lie. These bone cells will then connect through the canaliculus to each of the lamellae. Oh, sorry, did not mean to do that. So the canaliculus connects each of these lamellae together, and they all lead into the uh, central canal. And then on a larger scale, you have the outermost compact bone has its own set of lamellae called the circumferential lamellae. And these each have lacunae with the osteons inside of them, or osteocytes inside of them, sorry. Yes. And so these all connect together with the canaliculus as well as the Volkmann's canal or the perforating canal, which are larger canals that connect to the central canal of each osteon to allow for blood vessels and nervous vessels to go through these structures and all connect. And I believe that is all that I have for you guys. So if you guys have any questions, you can always leave a comment, and I will also include my email so you can email me there as well. Thank you.